this is with regard to the paper which we have conducted the exam today. So let's start discussing the questions in physics. So here comes the first question. So I'll read the question and solve the answer for this. So two vectors of equal magnitude P are inclined at some angle such that the difference in magnitude of resultant, so we know the resultant of two vectors is can be found using root of p square plus q square plus 2pq cos theta. But here equal magnitude, so I can write it as p square plus 2p square cos theta. So if you solve this, then you would get r as so if you solve this, then you have this as 2p cos theta by 2. As you take 2p square common, then you have 1 plus cos theta, which can be written as 2 cos square theta by 2. So this is the resultant of two equal magnitude vectors. Some angle, the condition is given that the difference in magnitude of resultant and magnitude of either vectors is, so it is given that r, which is resultant, minus any of the vectors is equal to 0.732 times either of the magnitude of the vector, which is p. So in short, you can write this as r is equal to minus p goes the other side, becomes p. So you have 1.732 p. So then the resultant r would be root 3 times of p, because the value of root 3 is 1.732. If the angle between them is increased by half of its initial value, let's find out the angle between these two by substituting this here. So then you have root 3p is equal to 2p cos theta by 2. So p got cancelled, and you're left with cos theta by 2 is equal to root 3 upon 2. So which means the value of theta by 2 has to be 30 degrees, and that theta is equal to 60 degrees. That's the angle between two vectors, but that's not the question. If the angle between them is increased by half of its initial value, so initial value is 60, so the new angle, let's say it is theta 1, which is 60 degrees plus half of 60 degrees, which is 30 degrees, then that will give you 90 degrees. So the new angle is 90 degrees. Then the magnitude of difference of the vectors is, so you are supposed to find the magnitude of difference of the vectors, which is like modulus of p bar minus q bar, so which is like root of p square plus q square minus 2pq cos theta. But we know that both the vectors are same, so turns out it becomes 2p sin theta by 2. As you can see that p and q are same, so this is the magnitude, modulus is magnitude of difference of two vectors p bar minus q bar, which is 2p sin theta by 2. We are supposed to find this, which we can say it as r dash. So 2p into the new angle you have to take here, so which is sin theta 1 here. So 2p into sin 90 by 2 is sin 45 degrees, and the value of sin 45 is 1 by root 2. So the answer becomes root 2p, which is option 2 for this question, this one. So let's go to the next question. The resultant of a bar and b bar makes an angle alpha with a bar and beta with b bar. So we don't know what is the resultant, so let's say here is the resultant. Let's say this is the resultant, r bar. So the resultant of a bar and b bar makes an angle alpha with a bar, so this is alpha, and beta with b bar, so this is beta. So now you have to understand that if b bar is greater than a bar, you can actually analyze it from diagram itself. If b bar is b bar in the sense b is magnitude of b bar, which is b is greater than a, since this has more magnitude, then the resultant tend to come towards this vector, then beta would be less. So if b is greater than a, then beta is less than alpha. And if a is greater than b, then alpha would be less than beta. So let's try to analyze it here. So alpha less than beta, first option cannot be the condition unless the magnitudes of a and b are discussed. So if a is greater than b, then alpha is less than beta, which is third option which we have discussed here. Second one cannot be the answer, because if a is less, then it subtends more angle here, alpha. And obviously if a is equal to b, then alpha has to be equal to beta. So turns out the answer is option 3. Let's go to the next question. Yeah, this is the third question. 5 forces, 2 Newton, root 3 Newton, 5 Newton, root 3 Newton and 2 Newton are respectively acting on a particle, as you can see in the figure. So the resultant of force on the particle P is, so you are supposed to find out the resultant here. We can do that here, see. So if you observe here, first I will find out the resultant of this root 3 Newton, this root 3 Newton and this root 3 Newton, which are inclined at an angle of 60 degrees. So the resultant of root 3 and root 3 would be r is equal to root of root 3 square, which is 3, again root 3 square, which is 3, plus 2 times of root 3 into root 3 is 3, and cos 60 is 1 by 2. So that will give you 2 got cancelled, and you have root 9, which is 3. So the resultant of root 3 and root 3 is t Newton, and it will be inclined at an angle exactly between these two, so which will be in this direction, 5 Newton. So now you have 5 Newton and 3 Newton, which is the resultant of these two, root 3 and root 3. So you can just eliminate these two. Now we can find out also the resultant of 2 Newton and 2 Newton. This 2 Newton and 2 Newton, which are inclined at an angle of 90 plus 30, which is 120. So you might know in vectors that if two equal magnitude vectors are inclined at 120, then the resultant is equal to either, which means like we can use r is equal to 2p cos theta by 2, which is the magnitude of resultant for two equal magnitude vectors. So you can write 2 times p is again 2. An angle between them is 120, and half of 120 is cos 60, which is 1 by 2. Then the answer is again 2 Newton. So the resultant of 2 Newton and 2 Newton is again 2 Newton, which is inclined exactly at half of that angle, which is 60 degrees. So then you have 2 Newton here again, which means now if you eliminate this 2 Newton and 2 Newton as well as root 3 and root 3, you're left with 3 forces which are in same direction. So which I can write as the resultant of all those forces is actually 5 plus 3 plus 2. So which is 10 Newton. So the answer is 10 Newton. But the 10 Newton is here, which is making an angle, take the other one, making an angle of 60 degrees with x-axis or 30 degrees with y-axis. So first option is correct, because 10 Newton making an angle 60 degrees with x-axis. Let's go to the other question. Yeah, this is a question on kinematics. If a car covers 2 by 5th of the total distance with speed v1 and 3 by 5th of the distance with v2, then the average speed is, this is an easy question. You have to find the average speed. Always remember the definition of average speed is simply total displacement by total time. So you can write it as V average is equal to total displacement by total time taken. So I'm indicating total time with capital T. So let's do this. If a car covered 2/5 of the total distance, let's say the line which is drawn here is total distance. So 2/5 is like 2s upon 5, and the remaining is like 3s upon 5. So this traveled with distance of this speed v1 and this with speed v2. So let's say the time taken here is t1, but I can write time is distance upon speed. So this is like 2s by 5v1, and you also have t2 is equal to 3s by 5v2. So you can simply substitute these two here, then you will get the answer. So total displacement is s, and total time taken is sum of these two. So 2s upon 5v1 plus 3s upon 5v2. So you can cancel s, and you're left with I think I'm writing it here. So also you can take 5 outside. The LCM of this is actually 5 v1 v2, and here you are left with 2 v2 plus 3 v1. So if you take the other side, the numerator, then the answer would be, I'm writing it here, so it has to be 5 v1 v2 upon 3 v1 plus 2 v2, which is the answer for this question. And this is a very basic question in kinematics, which is option D. I'm marking it here. So that's the answer for this question number 5. Let's jump to question number 6. Let me change the color. Yeah. If the velocity of a particle is given by v is equal to 180 minus 16x under root. So this is also an easy question from kinematics. So you can actually write it as v square is equal to 180 minus 16x. Also you can write this as v square minus 180 is equal to minus 16x. I am rewriting this in terms of a standard equation, which is v square minus u square equal to 2as. Then you have v square minus root 180 square is equal to 2 times of minus 8 into x. So if you compare it with the standard expression, if you compare it with the standard expression, then this is v square minus u square is equal to 2as. So in place of u, you have root 180, which isn't asked, but I'm just writing it. And the acceleration is minus 8, which is retardation. Hence the answer for this question is minus 8, which is option C. Let's solve the question number 7. The position coordinates of a particle moving in a 3-dimensional coordinate system is given by, so this is a 3-dimensional motion, but not a complicated one in terms of this particular question. So x is given as a cos omega t, and y is given as a sin omega t, and z is given as a omega t. So you are supposed to find the speed of the particle. We can do that. First we'll find out the speed along x-axis, which is dx upon dt, simply by differentiating that x. So then you have dx upon dt is a times derivative of cos omega t is minus sin omega t times omega, and vy will be equal to dy by dt, which is derivative of y, which is this one, is a into derivative of sin omega t is cos omega t, and internal derivative is omega, and vz is derivative of this z, which is simply a omega, and derivative of t is 1. So now if you want to speed, you need to simply use this magnitude of velocity, which is root of vx square plus vy square plus vz square. So that will give you I think a omega is common in all of them, so I can take it out, and I'm left with what is inside is minus sin omega t square plus cos omega t square, and plus there is 1 here, so 1 square. So you should know that this is 1 because sin square omega t plus cos square omega t is 1, and 1 plus 1 is 2. Hence the answer is root 2 times a omega. Options are not mentioned here, but you can note this, that this is the answer for question number 7. Now we have another question from vectors, which is question number 8. If a bar, a1 bar and a2 bar are two non-collinear, which means they are not in the same line, and they are unit vectors, that means if they are non-collinear, the angle between them is not 0. That's what the meaning of non-collinear is. Unit vectors, and if also given as modulus of a1 bar plus a2 bar is root 3, and you are supposed to find value of this thing, which is a1 bar minus a2 bar dot 2a1 bar plus a2 bar. So this is not a difficult question, but you need to understand what is a1 bar dot a2 bar. So let's solve for this one. The magnitude of this is like a1 square plus a2 square plus 2a1 a2 cos theta, but instead of a1 a2 cos theta, I can write it as a1 bar dot a2 bar. I hope you understand this. We know that dot product of two vectors is a bar dot b bar, which is ab cos theta. So I'm writing it as a1 bar dot a2 bar. So which is same as a1 a2 cos theta is equal to, this is magnitude, and actually the square of magnitude, because you have a root here, so which can be equal to 3. Since a1 and a2 are unit vectors, I can also write a1 and a2 are equal and they are equal to 1. So which is 1 square plus 1 square plus 2 times of a1 bar dot a2 bar is equal to 3. That will give you a1 bar dot a2 bar as 3 minus 2 is 1 and 1 by 2. So this is what I acquired here from this first statement. Let's solve the next statement here. Let's change the color. Yeah. So let's multiply this and this, and so this is 2 times of a1 square, and the next one is a1 bar dot a2 bar, which is 1 by 2. So I'm writing it as 1 by 2. I hope you understood this one. I multiply this with the second term. So a1 bar dot a2 bar, which is 1 by 2. And next minus 2 times of a2 bar dot a1 bar, and you should know that a2 bar dot a1 bar is same as a1 bar dot a2 bar, which is same. So this is 2 times of 1 by 2, because a1 bar dot a2 bar is 1 by 2, minus a2 square. So I wrote it as a2 square. So this is the value which you are, so I just multiplied this and also this. So we got 4 terms, and a1 is a2 and both are 1, so this is like 2 plus 1 by 2, and this is minus 1 minus 1. So 2, this minus 1 and minus 1 is minus 2, so 2 got cancelled. So the answer is final 1 by 2, which is slightly invisible here, but you're smart, so you can find it. This is the answer. Yep. Let's jump to question number 9. This is relatively a simple question from kinematics. Relatively from easy question from kinematics. So a particle starts from rest. I'll read out the question for you. A particle starts from rest. Its acceleration versus time graph is shown in the figure. The maximum speed of the particle will be. So, you know, speed of the particle is v. You know, any function, if you want the maximum or minimum of that function, the derivative of that function has to be 0, which is discussed in applications of derivative. So suppose f is a function, then df must be 0 for maximum or minima condition. Similarly, for velocity to be maximum, then dv by dt has to be equal to 0. So dv by dt is nothing but acceleration. So when acceleration is 0, velocity becomes maximum. So you can see acceleration is 0 at this particular time, which is t equal to 11 seconds, the acceleration is 0, and at t equal to 0, the acceleration is 10. And if you observe this graph, when the particle starts at t equal to 0, the acceleration is decreasing, but it is not becoming 0, it is like positive. So, and it came here, finally it became this. So this is the direct acceleration. So if you want to find out the speed, then you must know that speed v is integral a dt. So I got this from this particular equation, that acceleration a is equal to dv by dt. So v is like integral a dt, and integral a dt not only is the formula for v, but also it indicates the area under a and t graph. So which was actually represented above. So if you find out the area of this graph, that means that's the speed of the particle or maximum speed of the particle, because it is starting from rest. So you can actually be very precise by writing delta v here, but it still works here because it is starting from rest. So we'll find out the area, and area of that figure is very simple. So I'm writing it as delta v is equal to half times of base is 11 and height is 10. So this is 55 meters per second is the maximum speed of the particle, which is option B. Right. Let's jump on to this question number 10. The displacement time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at the point. So you are given a graph, and what you have to understand here is this is ST graph, S versus T graph. So if you find out, see, when a graph is given, one thing you can do it, you can find out the slope of that graph. Let's see what it indicates. And the other thing, you can find out the area of that graph, what it indicates. So here in this case, the slope of this graph is ds by dt, which is velocity. So we're done. That's what velocity is required in this question. So the instantaneous velocity is obviously ds by dt is instantaneous. Otherwise average would be delta s upon delta t. So this is the displacement time graph. You are supposed to find the instantaneous velocity of the particle, not to find, but when it is negative. So we'll simply start drawing the slopes at the points which are given. So yeah, so first we'll draw a tangent here at point which passes through point C, and if you observe, it is making an acute angle with x-axis, so slope is positive. Similarly D, again slope is positive, and if you also see F, the slope is positive. So what is left is E, and you can actually see that all these F, D and C, they are making positive slope, while if you observe point E, then if I draw a tangent, it would look like this. This is the tangent at point E, and it is making an obtuse angle with positive x-axis, and the slope is negative, because slope is tan theta, and tan theta for theta greater than 0 is like greater than 90 degrees is second quadrant, and second quadrant tan is negative, so slope is negative, which means instantaneous velocity of the particle is also negative, which is option E. Option D, but E is the point where the slope is negative. Now we'll move on to the next question, which is a body projected with a velocity u such that its horizontal range and maximum height are same. Then the maximum height is. It is also an easy question from projectile motion. For this, you should know the formula of maximum height and horizontal range. The horizontal range, I am writing it as u square sine 2 theta upon g. So this is also can be written as 2 times of u square sine theta cos theta, because sine 2 theta is 2 sine theta cos theta upon g, and the maximum height is h is equal to u square sine square theta upon 2g. So it is given that these two are same, so let's equate these two. So I am writing it here. So u square sine square theta upon 2g is equal to 2 times of u square sine theta cos theta upon g. So g got cancelled and also u square got cancelled. One sine also gets cancelled. Then this cos comes the other side, becomes tan theta is equal to 4. So tan theta is 4. If they are equal, so you are supposed to find the maximum height. So maximum height is u square sine square theta by 2g, but it is given in terms of only u and g. So it is simple that if tan theta is 4, you can simply construct a triangle, a right angle triangle, and represent some angle theta here. So this is like 4, tan theta is 4, or simply 4 by 1. So 4 by 1. This would become root of 4 square plus 1 square, which is 17. So this is 17. Then the maximum height is h is equal to u square, and what is sine from this triangle? Sine theta can be written as 4 upon root 17. So if you square of that, 4 square is 16 by 17, and this is 2g here. So this is 2g. So now if you rewrite this, it is 8u square upon 17g, which is option 4, the answer for this question. Let's move on to question number 12. A body of mass m is projected at an angle of 45 degrees with horizontal. Okay, fine. So this is the projectile motion at an angle of 45 degrees with horizontal. So this is the direction of initial velocity vector, which makes an angle 45 degrees with horizontal. If the resistance of air is negligible, fine. Then the total change in momentum when it strikes the ground. So this is actually simple. So this is u initial speed. So if you make component, this is okay. Let's instead of writing 45, I'll try to write it as theta, so that you will get a common general formula. This is u cos theta, and this is u sin theta. When it hits the ground, which is this point, it will still make an angle theta with horizontal. So then you have, this is again u cos theta, and this is u sin theta. Now I want you to observe that a change in momentum, see, when you take along x-axis, the speed is u cos theta, velocity is u cos theta, and also here velocity u cos theta. Then change in velocity along x-axis is 0. Change in velocity along x is 0. So there is no change. So that means the change in momentum is again 0. What changes is actually along y-axis, because initially along y direction the speed is, or velocity is u sin theta. When it strikes, the velocity is u sin theta, but in downward direction. Therefore, the change in velocity along y-axis would be u sin theta minus of u sin theta, which is 2u sin theta. But you want the change in momentum, I can multiply with mass simply. So 2mu sin theta is net change in momentum, because there is no change in momentum along x-axis for the entire journey, or at any point also, because at any point the horizontal velocity is u cos theta, so it will not change, so there is no acceleration. Now this is the answer, but theta is 45, so I'll substitute 45 here. Then you have 2mu sin 45, which is 1 by root 2, so it will give you root 2 mu, which is the change in momentum, and this is option where is that? Yeah, here, root 2 mu. I took it u, but the questionnaire has taken it as v, so it doesn't matter. Yeah, so we'll move on to the next question. There are few more questions from 13 to 25. I'll solve it in the other part of this video explanation.